Well, good evening, everyone. I am Michelle DeMarzo, the Curator of Education and Academic Engagement here at the Fairfield University Art Museum, and we are delighted to have as our speaker this evening one of Fairfield's own faculty members, Dr. Brian Walker from the Department of Biology, who's going to be talking about some of his experience with research in Antarctica. And his talk is being presented in conjunction with the exhibition Helen Glazer, Walking in Antarctica, which if you had not had a chance to see yet, it will be open after the talk until 8 p.m. tonight, and it closes on Saturday. So this is one of your last chances to get in there and see that incredible show. I do have to tell you, it is something of a miracle that Brian is speaking here this evening, because when we were originally planning the programming for this semester, last summer, whenever that was, as we were discussing, we were saying, Brian, you work on penguins. This is great. How often do you get to say the phrase penguin biologist? You do a lot, but we don't that often in the museum. You're going to come give a talk for us. And just as we were planning that, he learned that he had earned a Fulbright U.S. Global Scholar Award that would take him to Chile, Cape Town, and New Zealand this academic year. So that was fantastic for Brian. It was incredible for Fairfield. It's kind of a bummer for us in the museum because we thought there goes our chances of having him speak. And then he let us know that just by chance, his return to the United States would be the last week that the Helen Glazer show would be up. And he said he just might be able to squeeze in a public talk before the show closed. Now, from exchanging emails in the past few days, this man regrets what he agreed to. But it's too late. Jet lag or no jet lag, he is here, we have him. Brian Walker received his PhD in zoology from the University of Washington with a dissertation on stress responses in Magellanic penguins. After a few years of teaching on the West Coast, he came to Fairfield in 2006 as assistant professor of biology, and as of 2017 became full professor of biology. His research has focused around the responses of coastal birds like penguins to environmental stressors, including tourism and how that affects their breeding. And his recent Fulbright project looked at the effect of microplastics on Magellanic penguins. In Brian's time here at Fairfield, he has served as department chair, as associate dean of the College of Arts and Sciences, and as the director of multiple programs and institutes. His publications, fellowships, and awards are too many to list, so I'm just going to mention one of his recent accolades, and that is in 2023, he received the College of Arts and Sciences Award for Distinguished Student Advising and Mentoring. Please join me in welcoming Dr. Brian Walker.
Wow, thanks for that. Can you write that down and send it to maybe the president or someone? I mean, that'd be good. I can't see any of you. It's like, oh, I'm on a Broadway stage. I can't see any of you, so that's good. So I'm just going to talk to myself like I did last night at 1 a.m. when I was finishing this. Thank you all for being here. One of the reasons I was like, oh, why am I doing this? Because this talk that I'm going to talk to you about really has almost nothing to do with the research that I'm doing right now. It has nothing to do with what I'm in the middle with my Fulbright Award, which I could talk to you for hours about because it's really ripping at my heart. But we're going to go back to basically 1992 when there ain't no students here that were even alive then. And there might even be some colleagues of mine who might not have been alive then, and talk to you about really a part of my life that if I wouldn't have done, well, I have this thing here, what I did, I would not be here today, for sure. So this is Antarctica, and I spent, over the course of 4 years, I had 1 year off in the interim, on or near a very small island up at the tip of the Antarctic Peninsula called Seal Island. And this is just kind of a close-up where you can see, I'm not sure how this works. Is this, yeah, all right. So here we are, South America, and Seal Island was, does this work? Right up here, all right, at the tip of the Antarctic Peninsula, very close to Elephant Island. And Elephant Island gets its name because it kind of looks like an elephant head. And Elephant Island, if any of you are historians of Antarctic lore, is a really important island for Antarctic historians because it is on Elephant Island where Ernest Shackleton's men were stranded after the Endurance, of which there's tons of literature and stories about, got caught in the sea ice as Shackleton was going to try to regain his fame. A little bit of a backtrack. Ernest Shackleton was in competition with Edmundson, a Norwegian man, to be the first one to get to the South Pole. He lost. He was pissed. So what he wanted to do instead was recuperate it a little bit and go back and be the first person to cross all the way from one side of Antarctica to the other. And so he got on a ship and attempted to do that. And as they were going south, it got stuck in ice, eventually sank, and he and his men ended up on this island, Elephant Island. And there was a statue, a torso of him on Elephant. I took that picture from the ocean of him commemorating where he was. And we'll talk a little bit more about that later if we get time. So there we are on Seal Island. And we'll get to Seal Island, but I think it's also important for me to tell you how I got to Seal Island, besides on a boat. And so we're going to go back a little bit and show how the boy from North Dakota, all right, that's about as far as from the ocean as you can get and still be in the northern hemisphere, got to Connecticut. And as I said, without this Antarctic bit, I would never have ended up here. And this is where I try not to get weepy. I always, these days, really want to go back and thank the folks who set me on the path. And this is my family, my mom and my dad and my sister. My mom and my dad have both passed. But before they passed, they were in the field helping me with penguins. So they even dove in and came down to Argentina and spent a field season with me working on penguins. My sister did the same thing. You're going to see a trend here. I use my family as field assistants, and my sister came down a different year and worked with me as well, and then she came and she's visited, where are we? Connecticut numerous times, and so we do field work and then we drink beer. And then in the room is my partner, Matt Faber, who is a Fairfield alum, class of 1990, and he also came down and was a field assistant for me, and probably was the first time any bird ever pooped on him, but he wears that badge proudly. And then my mental support is my dog, Captain the Terrible Terrier, who I wish could be here, but he's home being grumpy. So, and the other thing that I also want to thank, besides my colleagues who are in the room, and all of you know them, this is a list of the research students that I've had in the 18 years that I've been at Fairfield University, and it's these guys that keep me excited about doing my research and excited to come to the lab and talk and work with them. And I think the majority of them that are working with me in the lab right now, the 6 up there in yellow, are here today, and I just want to thank them for their patience with me as I've been gone this semester, these 2 semesters, and excited about the stuff that we're doing, but we're not going to talk anything about that today. And expect they're going to start talking about that as they present their research, and I can just sit and watch. All right, so back to North Dakota. I went to a small liberal arts university, not unlike Fairfield is, Drake University. And as you know, those of us in the biology and the sciences really push for research opportunities for our students. And Drake, I was pre-med when I started, and then I saw the light and realized I didn't really want to do that and became much more interested in ecological studies. And interestingly enough, Drake University, notice it's about as centrally located as North Dakota, had a marine science program which required you to go away for a year. And I went to Texas A&M University down in Galveston. And it was there at this very small university where I first got into some hands-on field research, working with the Texas Marine Mammal Stranding Network, which is still very active today. And what we were, the focus of this group was to, when bottlenose dolphins that you see there alive came ashore either dead or injured, the call went out and we were called to go and try to figure out if we could help them or what happened to them. So I spent lots of hours, much to my roommate's horror when I came home with the clothes, knee cropsying these dolphins to see what would happen to them. And it got me the bug about doing field research, and it got me the bug from someone who's lived in North Dakota to do something with marine mammals. So I went back to Drake and finished my degree in my 4th year, and then off I went to Halifax, Nova Scotia to do a master's degree. And finally some good ocean, all right? Halifax, you can see where it is here. And I did a small research master's on Sable Island, which is a cool little island off the coast of Nova Scotia. And it's cool because it's known as the graveyard of the Atlantic. This is also a really cool, there's lots of literature about this as well. Over 350 ships were wrecked off this island. Here's one, The Perfect Storm. Those of you young enough, it was a movie. So that means it's real, right? If it's a movie, that means it's real. With George Clooney, you guys even know who that is, and Mark Wahlberg. So that movie was about an issue off the coast of Sable Island, and that's what it looks like. And the reason there's so many shipwrecks is that at its highest point, it's only about 15 meters high, and it's a sandbar. So back in the days without radar and things like that, these ships would run aground there. I did a small study looking at what was going on with male harbor seals to try to figure out which males were mating. Male and female harbor seals mate in the water, and so it's really hard to see who's being successful. So I did a study to try to figure out if we could look at what they're doing on land to see if they're successful. And so a couple of papers came from that. But this is where I really decided that this research thing is something that I want to do, and I really like working with marine mammals. They're really cool. So after the master finished, I got on a plane. That's not true. I drove from Halifax through North Dakota to get to Seattle, Washington, and ended up working and getting a job with the National Oceanic and Atmospheric Administration, NOAA, at the National Marine Mammal Laboratory in Seattle. And it is there when we finally get to Antarctica. And it was at that job that I had for 4 years that allowed me to go to this amazing place that transformed my life. So here we are now. We finally got back to where we are on Seal Island. Before I talk about some of the science we did, I want to talk to you a little bit about Antarctica, because I think it's not really well known about how Antarctica works. Back in 1959, countries of the world signed a treaty, the Antarctic Treaty, which established that this continent, where there's no one living permanently, should be used for peaceful purposes only, and that there should be a freedom of scientific investigation there and cooperation towards that end, and that shall continue through the duration of the treaty, and that the scientific observations and results from Antarctica shall be exchanged and made freely available. You can imagine with what's going on in the world around us now, that's kind of like, that wouldn't be happening in most places these days, but it's still happening in Antarctica. And this just gives you, I've resurrected some slides that we used back in the 90s to talk about what we were doing. And so you'll see some of these older slides. It pertains to all of the area south of 60 degrees south. So that blue circle, everything towards the South Pole under that blue circle is subjected to Antarctic Treaty policies. Again, as it said, it's supposed to be exclusively for peaceful purposes. There can be nothing nuclear there. A nuclear ship can't even visit. So an American nuclear vessel or a submarine is not allowed south of 60 degrees. And interestingly, no land claims by any country can be pursued until after the treaty has ended. And as we said, it applies to the sharing of information. But I want to tell you a little bit about those nations. So 12 countries signed the Antarctic Treaty back in 1959, and 7 of them actually claim part of Antarctica as part of their territory. But the treaty says that they can't do anything about it. And this map shows you those 7 countries and what part of Antarctica they think belongs to them. All right, and you'll see actually Brazil is thrown in here as well. They also claim part of Antarctica, but since they weren't a member of the original treaty, they don't count. My Brazilian colleagues would be offended by that. But so there are these countries that claim part of Antarctica, but they can't do it. Can't be anything can be done during the treaty. 3 of the 12 countries, Japan, Germany, and South Africa, they signed the treaty, but they have no claims to land there. And as you might imagine, Russia and the US, it says basis of claim. What that really means is if push comes to shove, we think we own it all. And we and the Russians, if push came to shove, think that they own it all and would have rights to it. So those are kind of these differences in our claims to land, but are not enforceable until the treaty expires. A few years later, about 20 years later, there was another international group that got together and a convention, and it was called the Convention for the Conservation of Antarctic Marine Living Resources, CAMLR. And the purpose of this was it was established by this international convention with the objective of conserving Antarctic marine life. So this is now a specialized group of researchers and countries that were really interested in figuring out, how to save those whales and seals and fish and things like that were down there. And it was primarily in response to an increasing commercial interest in Antarctic krill resources, which are a keystone component of the Antarctic ecosystem and were historically overexploited. And so this CAMLR group was divided into the commission, which is the political side of things, and the scientific committee, which was involved in doing the research. And the scientific committee was further divided into 3 different groups, one that were interested in looking at fish, krill, and the group that I was involved with looking at larger ecosystem questions. And that Kemp group, they were interested in looking at predators, so whales, seals, things like that, what they were eating, and how the environment was affecting them. And so these sites were set up to do long-term ecological monitoring. And I will stress the importance of long-term studies are invaluable. Too often we don't have enough funding to go out and do a study for more than 1 or 2 years, and you really can't get much data on what's happening with those groups if you don't have long-term studies. So these type of studies are really important. And Kemp still exists today, right? So those slides I showed you and talked about were from the 1990s, but I just copied this off of Kemp's website today, and these are now their more fine-tuned goals: to direct and record significant changes in critical components of the marine ecosystem within the convention areas, and to serve as a basis for conservation of Antarctic marine living resources, and to distinguish between changes due to harvesting of commercial species and changes due to environmental variability, both physiological and biological. And interestingly, back when I was working there, as it said in one of those early slides about Kemp, it was all about krill. But what was really about was all about the Japanese and the Norwegians who were harvesting whales. And so this convention was kind of put together as a way that the international community could start making policies to gently encourage our Japanese and our Norwegian colleagues to stop whaling. And I haven't been keeping up with what the status of whaling is now. I think the Japanese are still whaling. The Norwegians stopped for a while, but I think they're whaling again, and I think Iceland has actually joined the fray. But we won't get into the details or the pros or cons of doing this now. So our job was to look at functional relationships between the predators, the prey, us folks going down there and doing things like fishing, and really more important now, as opposed to 30 years ago, things like the environmental conditions and climate change. When we were down there in the 90s, we were worried about an ozone hole. And that was significant, but this global climate change that we're now documenting is a hell of a lot more significant and important than just a small hole. I'm not trying to belittle the ozone hole, but this component is much more important now. So these were the original 11 countries who were actively involved in doing research in the 90s when I were there. And you can see them listed here. Today, I went on the website last night. These are the countries that are now participating in the scientific activities still associated with Kemp. So these countries, the yellow ones, are new countries who weren't working in the Antarctic when I was working there, and the number of different sites in Antarctica where they are collecting the data that is used in making these policies. And you'll see that 4 of the original countries that were working when I was there are no longer involved. The 2 US sites are located, so here we are back on the Antarctic Peninsula. Seal Island is a little farther up here. There's only 2 island locations now that are actively involved in collecting Kemp data. And we'll get to why Seal Island is no longer involved in this group at the end, because it's kind of a sad story. And I'll probably need a tissue. So this was the group that we worked at, the Antarctic Ecosystem Program. And as we said, the first seal and seabird study, so there were 5 of us that would go to this island every year, and we were involved in collecting data that was standardized and organized across all of those research sites, so we could look at differences in feeding ecology, what the animals were eating, how successful they were at reproducing, the physiological parameters of how they were growing or not, and demography are long-term changes. And in fact, I think I even have some specific slides. And again, I apologize for the perhaps somewhat rough looking, but these are slides were made back in 1995. And so cut them some slack. So feeding ecology, we were measuring diet. We were measuring where the animals were off foraging when they left shore. We were measuring dive behavior, how deep these animals were diving, because where they dive is a very much of an indicator of what they're eating. And we were measuring how long they were gone on their feeding trips. If there's not a lot of food around there, they spend a lot more time. So just by measuring these feeding trip behaviors, activities, we can really get a good idea of what was going on with these animals eating. Reproduction, we were measuring the reproductive, how many pups the fur seals were having every year. And for the penguins, we were also looking at the breeding penguin success. How many of the 2 eggs that were laid, hatched, survived until those chicks went off to forage in the ocean. While those chicks and pups were growing, we would capture and measure them once a week to look at their growth rates. Obviously, great growth rates imply that there's great food around. And then we would also measure with penguins, we could measure how heavy those penguins were at the end before they went. The seals took a little bit longer to finish before, and wouldn't finish before we leave, so we didn't have any how well they did when they left, but with the penguins we did. And demography, this is the top of the island. There's a heck of a lot of penguins there. And this is demography. This is getting back to those long-term data sets, right? We could look at age-specific survival. So we had birds and seals that were banded, and so we knew how old they were. So we could estimate in a given year how well a 2-year-old penguin did versus an 8-year-old penguin, as far as reproductive behavior, success, how good they were at feeding their chicks. And then we also did censuses, and I can tell you, counting how many penguins there are on that picture is not easy. And we didn't have the whole digital stuff that we have now. We were standing on a cliff using binoculars and counting how many penguins were there. So we've come a long way, baby, in these types of studies. And again, the whole goal was to look at what factors are the most important in influencing the growth of these predators. And if you think about it, because the majority of them are eating krill, what we really wanted to measure was, given that there are X number of penguins, X number of seals, X number of whales out there, how much they eat, how many babies they're having, we could estimate how much krill that they need to have in order to survive. And then there were also groups in Kemp that were monitoring how much krill was there. So if you know how much these cool things need to survive, and you know how much is there, then you have really strong legs to stand on to say, okay, then you can take this much krill out of the system and everything will be okay, all right? So, I mean, we talked about whaling as well, but also back in the 90s, the actual krill fishery was important. And what was interesting is literally just about the time that I got there in 92 and 93, the bottom fell out of the krill fishery. Because what was interesting is the Japanese, who have very diverse appetites, they had decided that krill would be a good thing to help feed and so on and so forth. So they spent a lot of time fishing for krill, and they went out there and they did a hell of a good job fishing for krill. And so everyone was worried, oh, they're going to take too much krill. Well, about 2 years into it, the Japanese brought the krill home, and they realized it tastes like crap. And it's not really good to feed to anything. You could make fish meal out of it, but if you feed something that tastes like crap to a chicken or a cow, that chicken and cow is going to taste like what it eats, and it tastes like crap. So the bottom of the krill fishery, interestingly, fell out right about the time that I got there. So these are just some of the data that we were dealing with at the time. You see this ends in 1990. And you can see over the course of these however long that is, do the math, I'm not a mathematician, the whale hunting went down. That's good. All right, wasn't zero, but remember, this is thousands of whales we're looking at here. So you can see how the decrease of the whale harvest happened, which was good. Finfish, up and down. depending on environmental conditions and the going like for fish in consuming countries. And you can see here's the krill fishery. And like I said, the krill fishery increased significantly right about until that time where these data were taken in 1990. And I would guess if it continued, that line would probably be back down lower. What was happening with the cool, charismatic megafauna during the same time? So this graph, the light white line, shows you the abundance of emperor penguins. And you can see that during these 30 years, the abundance of emperor penguins decreased significantly during that time. Elephants, no, these are not Asian elephants or African elephants. These are elephant seals. They also decreased precipitously during that time. And this line, you're like, oh, look, it's a positive thing. It's a line's increasing. But what this line isn't abundance, it's crab-eater seal maturity. And what this is saying is that it was taking, for some biological reason, these crab-eater seals a lot longer to become mature. And when you're not mature, you can't breed. And when you have to live 2 years longer in order to be able to breed, that's 2 more years when something can affect you. So it looks like a positive line, but that's actually a negative thing. Adelie penguin abundance, that is this line here. Yep, that's this line here, showing some positive trends. But the most interesting one and exciting one, you might say, is the fur seal abundance that skyrocketed and increased astronomically. The reason that pattern was there is that up until the early 1900s, the fur seals were very popular for their coats. And so there was a huge hunt for fur seals. And countries and hunters would go down there and kill millions and millions and bring them back for their pelts to use. When that was outlawed, the fur seals came back wonderfully. So those are the trends and things that we were kind of dealing with. This is just a little bit of the data, just an example of what the data we were collecting looked like. So these are the weights of female on the bottom and male fur seal, Antarctic fur seal pups over the 5 years of the study before I arrived. I arrived in 1993. And the take-home message here is that there are significant differences between years. In 1988 and in 1992, the fur seal pups were fat and sassy. And in these other years in the middle, they were lower. And so the question is, what's driving that? And why are these things happening? And if you only looked at success rates at this one point, you'd be like, oh, seals are doing fine. Whereas in these years, they're not doing fine. So here's another reason where this repeated data, the long-term data sets, are important. All right, so having worked on those cute harbor seals in Canada, I was hired to go down to the Antarctic to be one of 5 biologists, and there was our head person, head honcho, who was the big scientist, and then 2 of us specialized working on seals, and 2 of us specialized working on penguins, and I was a seal guy back then. And I'm not going to really go much more into a lot of the data we collected, but I am going to show you, and there's kind of a point to this, I am going to show you 2 of the papers that I was able to publish based on some of the results that they were there. So if you read this paper, it says it was the effects of time depth recorders on maternal foraging and attendance behavior in fur seals. All right, so this isn't about how long they forage or differences. This is about how is it, and this is just the sample size of these instruments that we put on these individuals in order to make these measurements. And I'm going to show you what we needed to do back then in order to take these measurements. Here's a female fur seal, all right? And you have to catch them and glue a radio transmitter to their bum end. And that allows you to tell kind of where they are in a rough way and when they come back. And you want to know that because this other instrument called a time depth recorder cost back then $3,000. All right, and we glued it to the back of this animal. And what it does is when the animal goes to sea, it records pressure and time and diving characteristics. At $3,000 a shot, we want them back. So the radio transmitter helps us determine when they come back. And you can see, go backwards, the sample size, in this year with time depth recorders, we were putting out 14 of them times 3,000 in the 90s, lots of money. So if the animal came back one time and you missed it and it went off to sea again and then came back and the thing had fallen off, that was a sad day. The issue with this, and again, remember, we were doing this because Kammelar and Kemp was interested in these data to figure out what was going on with these animals, and that's all well and good. But we were concerned that this was not really helping those animals, and just doing this probably caused some significant difficulties in what they did. In addition, catching a female fur seal and putting those two things on her back was not an easy process. Fur seals exist in harem-like structures. Here's a male, a big male, and all these little gray ones are females, and these little ones are pups. All right? This guy does not like it if you're messing with his ladies. And so what we had to do is we use these poles, and we put a noose around the female, and we would gently pull her out while the male was looking the other way, while he was distracted. And oftentimes one of the other of us would be over here making a bit of a ruckus. And then we put this female into, literally, it looked like a guillotine almost, to keep its head restrained from biting us. And then we would glue these things to the back. And those of us that got hired around this time were kind of concerned about doing this, all right? Because it wasn't a pretty thing. And in fact, not under our watch, but in the past, there have been deaths of females that are doing that because these seals, they dive, right? And when they dive, they go into a dive response and they stop breathing. And so when they get stressed in this situation, they sometimes go into a dive response and they stop breathing and they don't start again. And that's a sad thing. So all these type of things were concerning to those of us young whippersnappers with idealism and dreams about what we were doing. So we were still collecting those data and reporting those data that Kammelar required, but in the meantime, myself and a couple of the other young bucks were writing these kind of papers to show. And this just is a blow-up of that picture I showed you before. You can see here's a female that already has the instruments on her, and here's another one. This just has the radio transmitter, and Mike and William were in there trying to, so this one is kind of keeping the male away, and there's the noose, and you gently pull them out. And this is probably weighing like 900 pounds. And if they come to you, that's kind of a scary thing. So point being that this is difficult to do. It's not a one biologist job. And what we showed, furthermore, in the data of that paper is that when you put both a big TDR, and they were about this big and about that size. So I'm trying to think, like a really good hefty cigar on the back of an individual with a transmitter, it caused the foraging trips durations to increase. Even with just the, let me see at the bottom. Oh, so and this is the trips during the foraging early before the pups were born. So they were gone, instead of an average of 75 hours with just the transmitter, they were gone on an average 110 hours when they had both of those instruments on. And you can see that's consistent, and if you do the math, that's statistically significant over time. So here we showed that putting those instruments on these animals was affecting what they were doing, and if it's affecting their trip duration, maybe it's affecting how good they can catch the food or how able to find it. So we were starting to raise some issues about how these data were collected. Here's just another graph from that paper showing now this is the mass of those females, okay? And this is the mass, and this is just a measure of how different they are than average, all right? And related to foraging trip duration. So the higher you are on the graph means that your foraging trip was longer than the average foraging trip, and that's not good, right? So what this shows is that little ladies have a significantly bigger problem with wearing transmitters and time depth recorders. That cause, when you're smaller, and it makes intuitive sense, right? But until you have data like this, you can't go to Kammelar and say, we need to reassess what we're doing, all right? So that is two of the results from that paper that I published. A second one that we looked at was a characteristic of the data that we were actually collecting itself. And if Dr. McSweeney should be here because she's the queen of statistics, and I always go to her for statistics. And this paper, you notice I wasn't the first author because I can hardly count, let alone do statistics. So my advisor, my coworker was the lead author, and I was in the middle. And I'm going to try to walk you through this somewhat complex graph. All right, the 6 different panels are just different diving characteristics. How long the diving trip was, how long it took you to go there and back, the mean depth of the dives you were doing while you were out diving, how far you dive. We literally measured the distance and summed it up over the complete diving trip, how long you were submerged, and how intensely you were foraging. So these are just characteristics. And what these three lines indicate is how big of a sample size, how many time depth recorders do you have to put on a female every year in order to pick up when there's a difference that exists between these characteristics. Okay? And the lines are documenting a 10% difference, which is the small dots, a 20% difference, or a 30% difference, which is the line, the black line. Now, if there is a 30% difference between what that group is doing and what this group is doing, you need a much smaller sample size in order to statistically pick that up. But as that difference gets smaller and smaller and smaller, as you don't eat 30% more than I did, your group only eats 20% more or only eats 10% more, in order to pick up that smaller difference, you need a much larger sample size. And one might argue that if you are unable to pick up these small differences, a 10% difference, that's significant. But in order to do that, you would need upwards of 40 to 80 time depth recorders times $3,000 every year. So here was another example of what we said to Camelot to say, okay, this is great data, but are we really able to use this to make biological significance? We often get caught up. We do our t-tests when we're doing our studies and things like that. And like, yes, statistical significance. That's great. You played by the rules of the math. But does statistical significance mean biological significance? All right? And it's often we don't think about those differences. So, and I would argue that if a particular animal over the course of an entire breeding season consistently gets 10% less food, that might be a significant problem for those females who aren't getting as much food. So as we were collecting these data for Camelot during the years I were there, I would sit in this blind. So there's a lot of watching animals as well. And we built this blind overlooking one of the penguin colonies and the seals. And this is where we put all those time depth recorders on. And so there was a radio receiver in this hut. And whenever it started beeping, when we were sitting there, we would look and like, oh, there is the time depth recorder. We would look at, oh, it looks like we need to get it. I'd send out for the posse. They would come, we'd catch it, remove it, so on and so forth. So I had a lot of time to sit and ponder and think during these years. And remember, this is the Antarctic during the winter. It's pretty much light, 22 and a half to 23 hours. So we were in there pretty much 24 hours a day doing this. We had lots of time to think. So, and what I kind of thought about as a seal biologist was that, this is a lot of work. It's really hard to do. I could seriously get bit. And I need these two brawny guys to help me catch these animals in order to do this. And I was a 140-pound weakling back then. I'm 120 or a 220-pound weakling now. But but because there were only 4 of us doing this work, I got to do a lot of penguin work as well. And penguins are just easier. All right, you see them, there they are. There were 250,000 pairs of penguins on this island. Island was only half a mile wide at its widest point. There were 300 seals there. All right, so already my sample size was huge. And they're really easy. Oops, I gave it away. They're really easy to catch. They bite, but you can handle it. They are kind of messy. That's all feces. And all of you who know me now know that I love penguin feces. But I pondered, yep, that's penguin poop. I had a big revelation during this time when I was down there. First of all, I wanted to control my science. I wanted to be in charge of designing the experiments, asking the questions, and collecting those data. All right? It was very hard for us under the Camelar umbrella of what we were supposed to be doing to do anything else. Because you can't go and interrupt the colony and disturb them when I got distracted. When you're doing something there for the Camelar stuff. So I thought, I want to control my world. I also wanted to move into more physiological studies. And if you know much about physiology, that means measuring an animal, maybe it's a blood sample, maybe it's breathing rates. It's much easier to collect those kind of data from a penguin than it is from a big seal. And finally, which implies that, penguins would be a heck of a lot easier to work with rather than seals or sea lions as I move forward. So because I wanted to control my own science, I knew I had to go back and get my PhD, right? And that's what I did. This was just kind of showing you again the difference between trying to do the studies this way versus trying to do the studies that way. And so that kind of got me back to do the PhD and set the pathway to get from there to here. And now we're not going to talk about the next 20 years from that. That's another study. So what I want to do right now is I want to pause if there are any questions at this point about that stuff. Because what I'll do afterwards is, because we're here with a photographic exhibition, I want to show you some of my photos. So if there's any questions right now, we can have some at the end as well.
Show us the photos.
All right. So the photos, these are not worthy of an exhibition. So back a little bit, what I didn't tell you, to get to Seal Island, we would fly to Port Stanley in the Falkland Islands or the Malvinas, if you're Argentine, and catch a tourist boat, a very high-end, very small tourist boat that even back in the 90s, the tourists were paying $25,000 to $30,000 to take this trip. And that's because that ship sailed from Port Stanley to South Georgia, down to Elephant Island, where it deposited us, then continued down the Antarctic Peninsula and back up again. I know at least one person in the room who wants to do this trip. And what's cool is that we became celebrities on this tourist trip because these people were joining our adventure where they were taking us to Seal Island and dumping us off for 5 months. They would be back in their lovely condos and doing their thing within 2 weeks, and we would still be living there for the next 5 months. And we would only get one other visit during that time. And they dumped us off, and so we became celeb. The night before we went ashore, there was always a big party, and half of the bottles in the bar were packed into some secret sacks and deposited on Seal Island with us. Compliments of those tourists. I shouldn't talk about that part. A couple cool points. South Georgia is an amazing place, and the animals that are there are fantastic. These are king penguins. All right, they're present on other subantarctic islands. They're the second largest penguin, so about that big. This is what they look like on South Georgia. That's one colony of king penguins extending all the way up this hillside, all the way to the top. And you can see the adults and their big fluffy chicks. All right, so it is a really awesome place to visit for the biology. It's really an awesome place also to visit for history. That whaling we talked about, I hinted at a little bit, back in the 1700s and 1800s, South Georgia was one of the processing centers for whales. And the reason I put this back up here is that it also, and I told you we were going to come back to Shackleton, South Georgia also played a role in Shackleton's survival after that big, horrible sinking of his ship. What happened when Shackleton was ready to go and cross the Antarctic, he arrived at South Georgia. They got everything ready in the Endurance, their boat, and they set sail going south. As they came south, I told you it got stuck in sea ice. The sea ice kept that ship, and it dragged it farther back north, and right about here is where it actually sank. And from there up to Elephant Island, his crew, he did not lose a single person, was on the sea ice as it floated. And they ended up on Elephant Island where the statue now is, right? And so, how does that relate back to South Georgia? Yes, it's where they started, but the amazing part of Shackleton's story was that I think he had about 30 crew people, and they knew that they were probably not going to be able to overwinter there because it's tough. And most of their provisions had sunk with the Endurance. They had seals and things they could eat, but they knew, and no one knew that this had happened to them. So Shackleton and 2 other people got in one of the lifeboats, and this was basically a rowboat, and set sail trying to get to South America, but ended up back at South Georgia. By chance, they found South Georgia. And when they got to South Georgia, they actually climbed up and over the mountain to the other side, something that has only probably been done 3 or 4 times since, and alerted the folks that this had happened, and ships were sent to save him. So it's an amazing, and there's the cabin that he was there, and lots of historical stuff there. So it's a great place to visit. So on that ship, okay, I got to have some ice in here, right? We're here for the ice. It's hard to take pictures of ice, and remember, this is in the 90s, so this is with like a regular camera, like a slide. Most of you students don't even know what slides are, like the little square things that maybe your grandpa and grandma have from. So. These are some of my ice pictures. Obviously, they're not going to make it downstairs. Maybe this one? I don't know. It's fantastic. And this is what you see every day when you're cruising around in the Antarctic. We got to the island. This is where we lived. That was our field camp, and that's where we stayed for 5 months. This Quonset hut is something that we had to put up every year and take down when we were ready to go. These other 3 buildings were permanent that had been set there. And as you can see, we're living right amongst the animals. The chinstrap penguins are right there. Here's a bunch of elephant seals that are hauled out. Here's a giant petrel. And they just know no fear, and they just hang out with you. I did a quick search of Seal Island last night, and this picture is actually on the internet. And that's me. I know you can't tell. But if you do an internet Google search for Seal Island, Antarctica, this picture comes up showing you our same field camp, and that's me. So I'm on the internets, even though you can't really tell it's me. We were a burly lot, and I shouldn't be, one of the year that I didn't go down, there was actually a woman on the trip. And she was there for 5 months with 4 other gentlemen, so it's not like you had to be a boy. But here we are. I think this was after we had been resupplied. Notice that the ship brought us a few Budweisers and those cigars. So this was us. Another picture of the motley crew. What you can't really sense here is that those of us in this picture probably hadn't showered in about 25 days. There was no fresh water on Seal Island, so all the water that we got came from bits of icebergs that had broken off and floated to shore. And if there wasn't enough ice coming ashore, we had strict calculations about how much water we needed. We had to go into strict water rationings, and the first thing to go was a shower. Now, you might be all thinking, oh my God, seriously, Walker, you went 25 days without a shower? 2 things. It was cold there. All right, not freezing cold. That looks, on a good day, it got up to 32, 35 degrees. And after a while, you just get used to that. So you don't sweat so much. So that's one thing. And when you're surrounded on an island with 500,000 birds and a bunch of seals, what you smell like ain't nothing compared to what the island smells like. So when we got picked up, it was kind of a bad thing. The boats that picked us up quarantined us in one corner. We had clothes that were specially delivered. Anyway, so yeah. When we left, all of the red building had to be taken down, and we would wrap it up. This is a shelving unit that was inside of it for storage and things. But the other 3 buildings stayed. I don't have pictures of it because when we arrived, there wasn't a lot of time to take pictures. But my second year when we arrived, the snow level was almost to the top of that building, came down this way, and halfway up that building. So before we could even start to reassemble our camp, we spent 2 to 3 days shoveling. All right? So that just kind of gives you an idea of what we were expecting. Hopefully it would survive from one year to the next. This just shows you how the animals just hung out with us. Our storage containers, here's a fur seal. Here's an elephant seal that after a snowstorm came up and because the snow accumulates more within the buildings and things, there was more of it than on the beach, and they like to be cold. So she came up and was hanging out in the water. Imagine your surprise if you wake up in the morning and you're not paying attention, you open that door to go speak to the Pope or whomever, and that's sitting there, all right? And here's a gymnast fur seal that was balancing on the beams. But what was amazing is that I had the fortune to spend 2 years, the first 2 years down there for 5 months at a time, seeing this every day. And most of you in the room know that I'm not a man of religion, but this is my spirituality. And being able to sit there and experience and share with these individuals the life of what they were doing was fantastic. And I still have the opportunity to do that at a smaller scale even today. So I've always been very grateful about this time here. And I think about Seal Island all the time. Just showing you, again, some of these are the Antarctic fur seals that we were working with. The pups are cute as hell. And interestingly, when you were working with the pups, the moms weren't aggressive. They would come over when you were weighing a pup, and they would just see, what's going on with my kid? What's going on with my kid? So they would come right up, and the males were a different story. The main penguins that we were focusing on is the chinstrap penguin, and I showed you a picture of the thousands and thousands of them. These are mean little birds. And as you walk amongst them, if we weren't wearing those high, extra tough boots, your legs would be raw, because they just peck, 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 peck. And what's interesting, I should have thought about this. They disperse themselves on those planes so that their neck, when they're both extended, they can't reach others. So no one can peck at them when they're sitting on their nest unless they're walking by. And when someone's walking by, they're doing the pecking. So it's amazing. Amongst themselves, they don't peck so much when they're sitting on their nest. But when you're walking through it, horrible. So that's the main penguin species. This is the other species. There is only about 50 breeding pairs of macaroni penguins that were on the island. If any student in the room can tell me why these are called macaroni penguins, I will find one of your professors and tell them to give you an A for the semester. Any idea why they're called macaroni penguins? Ha. Any adult know why they're called macaroni penguins? Yankee Doodle went to town riding on a pony, stuck a feather in his cap, and called it macaroni. That's where it came from. That's you guys are all like, what the hell song is that? That's Yankee Doodle Dandy. And that's why they're called macaroni penguins, because the feathers in their cap. So isn't that interesting? A couple of the seals that were there, I showed you the elephant seals. They're just blubber slugs. Their breeding season was over, so they were just hanging out and relaxing. We'd see them. The other one that was a visitor once in a while is a leopard seal. Leopard seals are solitary phocids, and they're the most dangerous and treacherous of any of the marine mammals. They're famous, you might have seen, they're famous for chasing penguins in the water. One day we were in a Zodiac, and I swear to you this is the truth, a chinstrap penguin jumps out of the water and lands in our boat. And we look, and there's a leopard seal in the water swimming around. Why? Because this is what leopard seals do. Leopard seals are famous carnivore predators, and this was actually one of our seal pups, already had her identification in it, and when we were out doing some population assessments on other islands, by coincidence, and this picture made the news in the science realm back then, showing a leopard seal right beside our Zodiac eating one of our seal pups that was identified. So I guess I'm almost done. I'm going to show you a couple more. It's a beautiful place. It's a magical place. It's incredible. Maybe some of these pictures would maybe be able to be on a wall somewhere. but not the one on the left. That's just showing you that I was handsome even back then. And the picture on the right is a cool penguin picture. I did, however, want to share one more thing with you. So this was Seal Island, and you know now that there are only 2 Kemp monitoring sites. And I told you that I spent 2 years down there. During my second year, while we were down there, there was a severe rock fall from here, which came down and smashed the back of this building. And in addition, and I don't have a picture of it, there was a beautiful natural arch that we would all walk under every day to get to the seal colony. And one night that collapsed. And if we would have happened to have been under it, we would have been smushed. So the US government decided that Seal Island was no longer safe enough for us to inhabit, because it would be 3 days before a ship could arrive if something happened. So my last year was spent tearing out the field camp. And as you might imagine from the Antarctic Treaty about how special it is and everything, you might have heard that story when you go somewhere, leave only footprints. That's literally what we did. We had to take every single, down to the splinter of man-made material or man-produced material off this island. And it's a gross joke, but we had an outhouse there, and we had been there for 8 years. All of the stuff that was under that outhouse had to be shoveled out and removed because that was not natural. And that's how serious the Antarctic Treaty is about making sure you leave no signature. Amazingly, the man who started Seal Island 8 years before approached the Kamilar Convention and asked for special permission to leave one thing on Seal Island. And this plaque is there. And this plaque says, personnel from the U.S. National Marine Mammal Laboratory, National Oceanic and Atmospheric Administration established a long-term research program on pinniped and seabird ecology in December of 1986 in support of Kamilar ecosystem monitoring programs, and studies were conducted annually until February of 1985. This plaque is dedicated to the men and women affiliated with the National Marine Mammal Laboratory who, during the years at Seal Island, gave so freely of their considerable talents, tireless energy, and insightful enthusiasm to promote effective Antarctic conservation based on scientific excellence. There's 24 names there. And I guess it's kind of like, and there's shit there too. So, yeah, that's all I got. If you have any questions, I'd be happy to take them and maybe get that light out of my eye.